Hello everyone. In this series of lecture we are going to discuss about the SQL subqueries and the joining performed in the SQL queries. So in this part we are going to discuss about the non-correlated subqueries. Before going into the non-correlated subqueries, let us understand what is a subquery. So subquery is basically a nested query where a query is within another query. The outer query result depends on the result generated by the inner query or by the inner queries. Now there are two types of subquery present in SQL. One is non-correlated subquery, which we are going to see a little bit later, and then we are going to discuss about the correlated subqueries. So in case of non-correlated subquery, the inner query or the subquery does not depend on the outer query. So the inner query is independent of the outer query. Now in case of correlated subquery, the inner query or the subquery depend on the outer query. Each and every row of the relation present in the outer query will affect the inner query in some way. Now the question is where can we write a subquery? In SQL we can write the subqueries after the select clause or after the from clause or after the where clause. We are going to explore all of these three a little bit in this video. Let's discuss about the non-correlated subqueries. So we are going to use two relations. The first relation is the employee and the second one is the department table. In employee table, there are 7 attributes and total 11 the number of records or tuple present there. The EMP number represent the employee number, ename represent the employee name, the job represent what job he do. There are 4 different types of job. P stands for president, M stands for manager, A stands for supervisor, and W stands for worker. The MGN number is the number of the manager who is managing that employee. Now, MGN number is the foreign key referring to the EMP number of the employee table. So, it is self-referencing table. Then the hire date when the employee have joined the company, his salary, and the department number represented by DPT number in which he is working. So, this DPT number will be the foreign key for the department table. So it will refer the DP number of the department table. In the department table, there are 3 attributes and 8 numbers of record. The DP number is the department number which is referred by the DPT number of the employee table. Then the department name and the location of the department. There are 4 different locations: Kolkata, Mumbai, Chennai, and Delhi, represented by KOL, MUM, CHE, and DEL respectively. So now let us discuss about the first example where we are going to use the subquery. Here we are going to show the name of the employees or the employees who are getting minimum salary in the company. The logic is that the inner query will give me the minimum salary in the department. So the minimum salary, if you go through that table, then you can see that the minimum salary is 20,250. And the steward is getting that minimum salary. So the output of the final query should be steward. So before going to the outer query, let us discuss the inner query, how we are going to use that inner query. So inner query tells you that the minimum salary of the company. So if we run this query, then you can see that it is returning 20,250. Now, if I run the total query looks like select ename. So we are selecting the name of the employees who are getting the salary which is equals to the minimum salary of the company. So this inner query is giving me the minimum salary of the company. So if I run this total query, then I will get the name of the employee who is getting the minimum salary. When we know that, it will be steward. So we are getting steward. In the next example, we are showing all the employees, name of the employees whose salary is not greater than the average salary. So the inner query, we are going to use the aggregate function avg to calculate the average salary, and then we will get that from the employee table. So this inner query will give me the average salary of this company. So let us check what is that value. So it is 37,954. Now we are going to show the name of the employees who are getting not greater than means less than equals to the average salary. So the outer query look like select ename from employee where salary is less than the inner query, that is the value we are getting, that is 37,954. So if we run that query, then we will get the name of Jones, Sunny, Alok, Stuart, John, and Barak. So let us verify with that table. Uh, you can see then Jones is getting less than the average salary. Alok is getting less than the average salary. Stuart is obviously getting the less than salary. John and Barak are getting less than the average salary. In the next example, what we are going to do, we are going to show the name of the employees working in Kolkata. So the inner query or the subquery, in the subquery, what we are going to do, we are going to find the department number represented by the attribute name DP number from the department table where location is equals to Kolkata. So let us run the inner query first. So we are getting the department number which are located in Kolkata. So 1000, 1004 and 1007. Now what can be my outer query? We are going to check the employees whose department number is similar to one of the department number given by the inner query. So here the equality operator will not work because we are checking multiple values returned by the inner query. So here we have to use the in operator to check multiple equality. So if we run that query now, we can find that the Smith, Jones and Stewart is working in Kolkata. Let us verify it with the table. So Smith department number is 1000. We know that it is in the Kolkata. 1004 is Stewart and 1007 the department number corresponding employees is Jones. So we are getting Smith, Jones and Stewart. Now let us write this query in a different fashion. Remember there are several ways to solve a particular problem in SQL. Here we are restricting our discussion in the subqueries only. This can be solved using the idea of joining or Cartesian product also. So let us write the query in a different fashion. Select ename from employee select ename from employee, and we are representing that employee by its alias name E. So we should write E dot ename. Now what we are going to do here, we are going to use the concept of subquery in the from clause, means after the from clause. So here what we are doing, we are selecting the DP number from department where LOC is equals to KOL. Now this inner query will give me a relation. We know that each and every query is actually return a relation. Then we are going to alias this relation by the name D. Now here we are writing the where clause of the outer query, where E dot DPT number is equals to D dot not equals to in D dot DP number. Why in? Because we are going to use or going to check multiple value with a particular attribute value. So let us check how the query is going to work. First we are selecting the ename from the employee the employee is aliased with E, then we are running a subquery to generate a relation which will be represented by D. What relation it will generate? In that relation, we will have all the DP numbers whose from the department table where the location is Kolkata. So these are my two different relations. One is represented by E, another is represented by D. Now my job is to find the E dot department number, so employee table department number, which is present in this relation, the D relations department number, right? So if I run that query, and we are going to get the similar result as the previous query. So you can see that we are getting the similar result as the previous query. So here we are using the subquery in the from clause. So after the from clause. Now next example, what we are going to do. So that is already done. In the next example, what we are going to do, we are going to find the highest earning manager. So the inner query will give me the maximum salary of the managers. How can I get that? We are going to use the max aggregate function to get the maximum salary, and we need to use another clause where the job will be equals to M. M stands for manager. So if we run this inner query, we will get the highest salary of the job profile manager. So this is 45,550. Now the total query will look like this one. Now understand the outer query. What we are doing? We are selecting the ename from employee where job is equals to M, and the salary will be equals to the inner query, that is the maximum salary of the manager. Now understand why we have used this clause, this condition, job is equals to M. Suppose an employee who is not a manager but getting the similar salary as the highest earning manager, that is for in this case this is 45,500. So employee who is not manager but getting salary 45,500, his name will also be shown, but we need to find only the highest earning manager. So this condition is actually ensuring that the employees who are name we are going to show are the managers. So let us run the total query or the final query and see what the output we are getting. So we are getting same. So let us verify with that with our table that the same is the result, correct result or not. Remember, 45,500 is the maximum salary of the manager. Let us take, there are three managers. One is getting 45,000, another one is getting 43,500, and the third one is getting 45,500. So the maximum salary is 45,500. So inner query work properly. Similarly, that employee who is getting the maximum salary of the manager is Sammy, and his job profile is also M. So we are getting the output we are expecting, or we are getting the actual output. The next one, show all the employees having same job profile with Alok. So first in the inner query we have to find the job profile of Alok. So the inner query look like select job from employee where ename equals to Alok, and the inner query, remember Alok's job profile is a single job profile. So the inner query is going to return a single value. That is why we are using the equality operator, the equals to operator, to check with the job of the employee. So what we are going to do, select the employee name from employee table where job is equals to the inner query, where the inner query is giving me the job profile of Alok. So let us run that one directly. Now here we are having some trouble with the quotation symbol, so let us change that one. So we are going to see that the employees who are having the same job profile is with Alok is Alok R, Sunny, Alok, John, and Bharat. Now, here you can see that the Alok name is appearing once again because he is also having the same job profile as Alok. So let us try to remove the name of Alok also. So in the outer query, what we are going to do, we are going to add another condition and ename not equals to Alok. So it will exclude the name of Alok from the output we are getting, right? So let us verify with our table. So job profile first. Let us check what is the job profile of Alok, the inner query. The Alok job profile is W. That is, he is a worker. So my final query will show all the workers: Sunny, Alok, John, and Barak. Let us see we are getting that or not. Sunny, Alok, John, and Barak. And as we have excluded the John, excluded Alok, so we are not seeing the name of the Alok in this query. Let us take another example. Show all the employees having more salary than some manager. So the inner query will give me the salary of the managers. Let us first clear the screen. Sorry, we are getting this error because of the quotation symbol. So these are the salary of the managers. Now here we are going to use a special kind of clause, that is the sum clause. What it will do, let us understand the outer query first. See, we are selecting the ename from employee where salary will be greater than of any of the salary returned by the inner query. So inner query is returning a multiple value, So the the greater than cannot check with multiple value. That is why we are going to use the sum clause. So what it will do, it will check that the value returned by the inner query, the salary, is greater than any value or the sum value returned by the inner query. So let us run this query. Let me first change the quotation symbol. So we can see that the Smith, Sammy, Allen, and Barak, they are getting more salary than any of the manager. Now, this sum clause can be replaced by another clause, that is any clause. So we are getting the same result. In this query, the name of the manager who is getting more salary than any manager, that will also be shown. So how to exclude the name of the managers? Just add another condition and job not equals to M. So it will exclude the name of the managers. So we can see that Smith and Blake are the employees who are getting more salary than any of the manager. So Smith and Blake. Blake is getting 45,000, so he is getting more than Word, who is a employee, who is a manager. So his name is shown in this table, right? Now let us check the last one. Let us check the last example. Show all the employees having more salary than all supervisors. So in the previous case, we are checking that a person is getting more salary of some managers. Here we are checking that per employee should get more salary than all supervisor. So here, instead of using the sum clause, we are going to use the all clause. So it will give me the salary, the name of the employees who are getting more salary than all of the salaries present in the inner query. And in the inner query, what we are doing? We are getting the salaries of the supervisor represented by job equals to S. So if we run this query, so we will get all the employees who are getting more salary than the supervisor. And let me first change the quotation symbol. So Sammy and the Smith is getting more salary than any of the supervisor. Let us verify it. So the supervisor's salary, the job profile is S, 37,000, 45,000 and 20,250. So the person who are getting more salary than all the supervisors will be Smith because he is getting 75,000 and Sammy who is getting 45,500. So that is how we are going to write the non-correlated subqueries in SQL language. So we have discussed about how to write a subquery in the from clause or in the where clause. Let us discuss how to write a subquery in the select clause, means after the select clause. There are no restriction to write a subquery in case of after from clause or after where clause, but there is a restriction to write a subquery in case of the select clause. The restriction is that the subquery or the inner query in the select clause have to return, must return a single value only. It will not allow any subquery which is returning multiple value. Right? So we can write only the subqueries which are returning a single value in case of the select clause. So let us write a query like that. The problem statement is we have to find the difference between employee's salary and the average salary of the company. Is that clear? We have to find the difference between the employee's salary and the average salary of the company. So let us first run a query which will give me the salary in employee name and his salary. So select ename, comma salary from employee. So this will give me the employee name and his salary. Now, if we want to find the difference between salary and the average salary, what we need to do? In select clause, we need to subtract the average salary of the company from the salary. And that, how can I get that average salary? By using a subquery. Remember, average salary is a single value, so it is allowed in the select clause. So let us run that query, write that query. Select ename then salary minus select average salary from employee, and we are going to represent this attribute as difference, as diff. Now where the ename and this where the ename and this salary will come from? It will come from the employee table. Sorry, I haven't balanced the bracket. That is why I am getting the error. Yep. So you can see that the employee and the difference between average salary, you are getting that one. So let us change the average salary by maximum salary. So it will give me the difference between average salary, difference between the salary of a person and the maximum salary given by the company. So we are getting that one. Now let us write a query which will give me the year of experience of the employee. So here, instead of salary, what we have to do? We have to subtract the current date by the by the higher date of the employee. So that difference will give me a number of dates. We have to divide it by 365 to get the year, right? In the select clause, we are going to find the system date. So how can I find the system date? Select sysdate from which table? From the dual table, which is a dummy table present in case of Oracle. Minus, what we have to minus? We have to minus the higher date. So this will give me the difference in date. So we have to subtract that difference in date by 365 to get the year, and we are representing this with YOE, year of experience. So this e-name and this higher date, no, sorry, this will be higher date, not high date. Now let us check how it is working. Select e-name, that will come from this employee table, and select sysdate, that will come from the dual table, minus the higher date which will come from the employee table, and this difference will give me a number of days which we are dividing it by 365 to get the numbers of year, and we are representing it by the YOE alias. So we are getting the year of experience of each and every employee. Let us write a query where the name of the employee and his corresponding department name will be shown. So what will be that query? Select ename, and in the subquery, remember this problem can be solved in many different ways. We are using the concept of subquery in the select clause. So here the inner query or the subquery in the select clause will be like this. Select tname from department where, let us represent that department by D, alias the department by D, where E dot DPT number is equals to D dot DP number. Now what is this? What is this E? That is the alias of the employee table. So let us make that e.ename. Now let us run this query. Let us run this query, and you can see that each and every, it will be better if we alias this as DPT name. So it is showing that employee name and his corresponding department name. Now in this query we haven't used the idea of the non-correlated subquery. Here we have used the idea of the correlated subquery. And we know that in case of correlated subquery, inner query will depend on each and every row of the outer query relation. So here the outer query relation is represented by E, which is affecting the result of the inner query. So this is an example of correlated subquery, and we are going to explore more about this in the coming video lecture. So that's it for today's video. See you in the next one, where we are going to discuss about correlated subquery in details, as well as the joining present in SQL.